Welcome to our first at-home lesson. Today we're going to talk about factoring trinomials. Now, back before spring break and we were out of school, we were able to multiply two binomials. So that's when you had something like x plus 2 times x plus 3. And we used the box method, and we would multiply using the box method, and we would get a trinomial. So what we're going to do now is we're going to take our trinomial and we're going to turn it into two binomials. In order to do that, we're going to use what we call the x method. So you will take and you will make an x on your paper, and then we're going to label this trinomial because it's in standard form, we're going to label A, B, and C. And in the top part of this x, you're going to take A and multiply it times C. So that would be 1 times 20. 1 times 20 is 20. And then the bottom part of the x, you're just going to write the B value, which in this case is 12. Now here comes the most difficult part, but it's really not that hard. We're looking for two factors, two numbers that are multiplied together, that multiply to 20, but add up to 12. So we can do that over here. So factors of 20, 1 times 20. Well, if I add those two numbers together, I get 21. And then we could do 2 times 10. 2 times 10 is 20, and if we add those two numbers together, we get 12, which is what we're looking for. So these are my two factors. I'm going to put one on the left and the other one on the right. The next thing we're going to do is we're going to take these two factors and we're going to divide them by our leading coefficient. Remember, A is our leading coefficient. So since A is 1, I'm going to divide both of these by 1. 2 divided by 1 is 2. 10 divided by 1 is 10. Then I rewrite those as my two binomials. So I have x plus 2 times x plus 10, and that is my factored answer. We're going to go ahead and do another example. This is example number 2, and this is actually in your notes that we sent out about factoring. So this is example number 2. If you'll notice, my A value this time is not 1. So the first thing we're going to do before we start factoring, we're going to see, can we factor out a greatest common factor? So what number do all of these have in common? If you notice, we have a 3, a 9, and a 6. We can factor out a 3. So we'll take a 3 in the front, and if we do 3 divided by 3, we just have 1, so now I have 1x squared. 9 divided by 3 is 3, so this becomes 3x. And 6 divided by 3 is 2. So now I have my greatest common factor is 3. And for now, I'm just going to put that over to the side. I don't have to do anything else with it. Now, I'm going to do my x method. So I make my x. I'm going to do A times C. So 1 times 2 is 2. And my B value is 3. So we have our 2 up here, that is A, is what we're multiplying to get. And we want our factors to add up to 3. So once again, factors of 2, 1 times 2, and that's really all there is. And if I add 1 and 2 together, I get 3. So my factors are 1 and 2. Now remember, my A value here, not my original, but my A value after I've factored out a 3 is 1. So I'm going to divide both by 1. 1 divided by 1 is 1. 2 divided by 1 is 2. So those are my factors. So I have x plus 1 times x plus 2. All we have to remember now is to bring this 3 down and put it in the very front. So this is the factored form of this trinomial. All right, guys, so we're going to move on to example number 3. And let's look at example number 3. And I'm not going to label my A, B, and C this time until I have factored out my greatest common factor. So if I look at these numbers, 6, 8, and 14, try to find a greatest common factor. Well, let's see, I have 6 is 2 and 3, 8 is 2 and 4, and 14 is 2 and 7. So my greatest common factor would be 2. So I'm going to go ahead and factor that out. So I'm going to put a 2 in front. 6 divided by 2 is 3x squared. Negative 8 divided by 2 is negative 4x. And negative 14 divided by 2 is negative 7. Now I have factored out my greatest common factor. Now I'm going to go ahead and label my trinomial. So this would be A, B, and C. So I'm going to go and factor that using the x method. So remember, in the top of my x, I do A times C. So 3 times negative 7 is negative 21. And my B value is negative 4. So I'm looking for two numbers that multiply together to give me a negative 21 and add up to give me a negative 4. So since I know that when I multiply, I have to get a negative number, I know one of my factors is going to be negative and the other factor is going to be positive. So let's look at some factors of negative 21. Well, we have negative 21 times 1, that would be negative 20. Then we have negative 3 times 7, that gives me 4, which I'm looking for 4, but I need a negative. So let's just switch the negative sign. So let's have a negative 7 times 3. Negative 7 plus 3 is negative 4. So these are my two factors. So I'm going to do negative 7 and a 3. Now my A value now is 3. So I have to divide both of these factors by 3. So negative 7 divided by 3, well, that doesn't divide evenly. It's going to give me a decimal. So I'm just going to leave it as negative 7 over 3 because that is its lowest form. I can't simplify it any further. But 3 divided by 3 is 1. So when I rewrite my factors, I'm going to start with this one because I got a whole number. I'm just going to do x plus 1. But now, because it let this stayed a fraction, this goes in front of the x, like 3x, and then minus 7. So then I have to remember to bring down the 2 that I factored, put it in front, and that is the factored form of this trinomial. Okay guys, this is our fourth and final example. So the first thing we're going to do is we're going to check to see if our trinomial has a greatest common factor. So we have a 2, a negative 11, and a positive 15. Well, 2 is a prime number and it's 2 and 1. 11 is also a prime number, which is 1 and 11. And then we have 15. So there is not a greatest common factor. So we're just going to go ahead and label A, B, and C. So now we're going to go ahead and draw our x. Remember, the top of the x is A times C. So that would be 2 times a positive 15 is 30. So that's the number we're looking to factor. And then our B value is negative 11. And one thing you have to realize here is because my C is positive and my B is negative, I know that both of my factors have to be negative because a negative times a negative is a positive. And then when I add those together, the number stays negative. So I'm looking for two numbers that multiply to give me 30, add to give me negative 11. So factors of 30, negative 1 times negative 30, that gives me negative 31. Negative 2 times negative 15, I add those up, I get negative 17. So I'm getting closer. And then I have negative 3 and negative 10. If I add those up, I get negative 13. And then I have negative 5 and negative 6. And if I add those up, I get negative 11. So these are the two factors I'm going to use. Negative 5 and negative 6. And then my next step is to take my two factors and divide them by my leading coefficient. And my leading coefficient is 2. So I'm going to divide both of these factors by 2. Negative 5 divided by 2 gives me a negative 2.5. So I'm just going to leave it as a fraction. And that is in its simplest form. Negative 6 divided by 2 is negative 3. So now I'm going to rewrite each of these as a factor. So I'm going to do this one first. And so it would just be x minus 3. And because this state of fraction, the 2 goes in front with the x, and then minus 5. So this is the factored form of this trinomial. And one thing I didn't tell you guys is when you get your answer, you can use the box method to go back and check that it's correct. So if I use the box method, I would take this first factor, put it on the top. This second factor, put it on the side. And then I multiply to fill in the box. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Negative 5 times x is negative 5x. Negative 5 times negative 3 is a positive 15. Then I combine like terms across the diagonal. So I get 2x squared. Add these two. Negative 6 and negative 5 is a negative 11x plus 15. And that's where I started. So I know that I got the correct answer. Thank you.